Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to find the concentration of anions for a weak diprotic acid solution. So in previous videos we talked about how to find the H plus concentration for a diprotic acid solution, but what about finding the anion itself? So let's go over this. So when we have a diprotic acid here, you'll see that there are, again, two ionizations that go on for a diprotic acid. If there was a triprotic acid, there'd be three. So here is my generic uh, weak diprotic acid. So it's going to undergo its first ionization. So hydrogen is going to come off, be transferred to water, form the hydronium ion, and then that's going to leave behind the HX minus anion. And so there's a Ka1 value for this process. So this is the first acid ionization energy or ionization constant for this process. So then the second process is where this anion can undergo a second ionization. And so the H plus will come off, bind with water again, form more H plus, and then you're left with the anion. So in this video, we're focused on, well, how do I find the concentration of that ion there? Okay, so we have to first go back to the first ionization. And so in previous videos, I've shown you how to find the H plus concentration for the first ionization, where the first H plus comes off. And so what we found, and this is just a recap. So here's the ice table. So again, remember, you ignore the first ionization, and especially if the Ka2 value is much, much smaller than the Ka1, and we can ignore this and we can ignore the auto ionization of water. So here's an example. So using my generic equation, let's say we start with an ice table, right? This is the way we would normally start if we're going to find the H plus concentration. So we would fill in our table, and let's say we start with H2X concentration of a 0.1 molar, right? So we start with 0 or pretty much 0 H plus. Again, remember, in pure water, there is some H plus, but it's very, very small. So it's effectively 0. And we don't have any HX right now because we are at the initial point of the reaction. So then we do our ice table like we normally do. We do minus X for the amount of acid that's going to ionize. So we're going to lose some of that acid, and we're going to gain the same amount of H plus and the anion HX minus. We write up our equilibrium expressions for these species. So we add these together, we get 0.1 minus x x plus x. And so now that we have our equilibrium expressions for the concentrations of these species, we can plug them into our Ka expression here. And of course, we'll get the x squared. Since both of these are equal to x, that's going to be x squared over 0.1 minus x here. Now, of course, at this point, we would do the x is too small approximation to simplify it, and then see if it's valid according to the 5% rule, or if it's not valid, we would then use the quadratic formula or use the method of successive approximations. But let's say we go ahead and do this. We do the simplification. We x is too small approximation. It's valid, and we get x is equal to 2.8 times 10 to the negative 3. And that x is equal to the H plus concentration and the x or the HX minus concentration here. So this concentration, this x value is equal to these values here at equilibrium. Okay, so that was the first step, and that's what we did before when we wanted to find the H plus concentration. But now the question is, how do we find the concentration of the anion, this X2 minus? Well, in that case, we have to do another ice table. So what we need to do now is, since this is the concentrations of H plus and the XH minus ion, then we can use those as the initial concentrations of our next equation here, our next process here. So we're going to use this equation and do an ice table with that. Okay, so here's my ice table with the second equation here. And you'll see that I have the HX minus. So here's my HX minus. And so here's, and then I have the H plus concentration that's going to be formed from there. And then, of course, my X2 minus. So I should fix that. Not A2 minus, but X2 minus. Okay, so this I now set up my ice table for the second equation. And so now what am I going to use for the initial conditions for here? Well, those are going to be the equilibrium conditions that I got for my first ionization reaction from here. So since X is 2.8 times 10 to the negative 3, and that's your H plus concentration, and your X and your HX minus, that should be a clear minus concentration, I'm going to put that in for H plus and HX minus. So here, since this is 2.8 times 10 to the negative 3, I'm going to put in 2.8 times 10 to the negative 3 for my initial HX minus concentration, and I'm going to put 2.8 times 10 to the negative 3 for my H plus concentration there. What's my concentration initially of my X2 minus ion or anion? That's going to be 0. So now I have the initial concentrations. I have my Ka2 value, so that's given to me. So then all I do is I fill in my table again. So this is going to be minus X for the change. So I'm going to lose some here, and then I'm going to gain the same amount here and the same amount here. And now for equilibrium, it's going to be 2.8 times 10 to the negative 3 minus X. Here it's going to be 2.8 times 10 to the negative 3 plus X. And here's going to be just X. And so now I have the equilibrium expressions for the concentrations of these three. And now I can put that into my Ka expression. So Ka2, this should be Ka1. So Ka2 is going to be equal to now the X minus or H plus, so H3O plus concentration multiplied by the X2 minus concentration all over the HX minus concentration. So now I have these expressions. Again, I can plug those expressions into my equation here. I know what the Ka2 value is. That should be given to me. And then all I'm going to do is solve again for X like I normally would. So I would maybe try the X's small approximation, maybe get rid of the X's and simplify and see what I get. And then make sure that obeys or follows the 5% rule. And so that's it for trying to find the concentration of X2. So you'll be able to solve for X, which is going to be your X2 minus anion concentration. And so a couple of things to point out when you do this. One thing is that so your anion concentration, and let me do that as X since I'm using X. So the anion concentration of your diprotic acid is going to be equal to the Ka value, Ka2. So that's what you're going to end up with for your anion concentration. So if you do the math, that's what it comes out to here. So that's going to be the same. So the concentration of your anion for your diprotic acid is going to end up being equal to the Ka2 value for all diprotic acids in which the X is too small or the X is small approximation is valid. So if that approximation is valid, if you do that approximation and it comes out valid, you should find that your anion concentration ends up being equal to the Ka2 value of your second ionization. Okay. The other thing to keep in mind is that you'll notice also that the concentration of H plus that's produced by your second ionization is going to be much smaller than compared to the very first one. So that's going to be something that you're going to see as well. That's it for finding the concentration of anions for a weak diprotic acid solution. In other videos, I will actually do some example problems, but this here is the general strategy. So again, you first find the concentration of these two doing your first ice table using the initial concentrations of your acid that you're given. Once you get your X value, once you figure out what the H plus concentration is, that's going to be the same as your HX minus, your anion for that first step. And then for the second step, you do another ice table in which you take the values of the H plus and your anion from the first step and put those equilibrium concentrations as initial concentrations in your second table for the second step. And then you just do the ice table again and you solve for X the same way you normally would. I hope this video was helpful. If you enjoyed this video, if you learned a lot, if this clarified a lot of stuff for you, please make sure you like this video, subscribe to my channel, hit that notification bell so you'll be notified by other videos I put out. Put a comment down in the comment section. Let me know what you think. Ask me questions if you got them. Thanks for joining me. Have a great day.